question of how much water to pump from a shallow aquifer without encroaching upon vegetative ecosystems has no straightforward answer. Excessive or unregulated pumping has the effect of lowering the water table and negatively impacting the vegetation accustomed to getting its water from the unsaturated vadose zone or the saturated groundwater zone. Therefore, enlightened groundwater management must reach beyond hydrogeology to encompass the closely related fields of ecohydrology and ecohydroclimatology. This will prevent the anthropogenic aridization of the ecosystem and the consequent degradation of the vegetal cover. Societies have pumped groundwater for more than 100 years. Typically, societies resort to groundwater use when all the available surface water is already committed, or when the use of groundwater is shown to be less costly than that of surface water. In 2010, fresh groundwater withdrawals in the United States were estimated to be 76 billion gallons per day, which is 21.4% of the total water use. In general, the drier the local climate, or the more developed a society, the greater the use of groundwater. This figure shows groundwater withdrawals in the United States for the year 2010. It is seen that most of the groundwater use is in the western half of the country, particularly in California, which has a highly developed economy, coupled with a prevailing arid, semi-arid climate in a substantial portion of its area. All water on the surface and subsurface of the earth originates in precipitation. From an average global perspective, about a third of precipitation shows up as surface runoff and is eventually discharged into the oceans by exothermic drainage systems. The remaining two-thirds are used by the natural ecosystems, returning to the atmosphere by vaporization, normally referred to as evaporation. Evaporation consists of 1. The evaporation from bodies of water, including endorheic or partially endorheic drainage systems such as ponds, lakes, and wetlands, and 2. The evapotranspiration from terrestrial ecosystems, both natural and artificial. The fraction of precipitation that manages to infiltrate into the ground, into soil or fractured rock, may follow one of two paths. 1. Move down in a predominantly vertical direction to join the groundwaters and eventually join the base flow of neighboring rivers, thus returning to the ocean as surface runoff. 2. Move up, returning to the atmosphere by vaporization, effectively short-circuiting the hydrologic cycle. In nature, surface water and groundwater are in constant movement, interacting in a variety of temporal and spatial scales. In turn, surface waters may become groundwater, and vice versa. Surface water flow is typically fast-moving, while groundwater flow is slow. Depending on the climate, streams and rivers may be ephemeral, intermittent, or perennial. Therefore, the quantities of surface water vary greatly, from zero for dry creeks in semi-arid and arid regions to substantial in rivers of humid regions. A significant difference between surface water and groundwater is that while surface water, that is, surface runoff, may or may not exist in a given place or setting, groundwater is always present at a certain finite depth. The depth to groundwater is a function of the local geology, geomorphology, and prevailing climate. In humid climates, the water table lies close to the surface, usually within a few feet. Conversely, in arid climates, the depth to groundwater is generally much greater. Typically, the drier the climate, the greater the depth to groundwater. All ecosystems need a certain amount of water for their continued survival. Their water needs tend to vary greatly. While some ecosystems seem to thrive with very little water, others require great quantities of it. Nature has made it possible for ecosystems to adapt to whatever water is readily available in the vicinity and to sustain their livelihood on that basis. Recurrent droughts typically lead to water stress and, if persistent, to the eventual partial or total demise of vegetative communities and ecosystems. In nature, water, that is, moisture or humidity, originates in the following five sources. A. As direct precipitation. B. As surface water or surface runoff, as wetlands, ponds, lakes, streams, and rivers. C. As near subsurface water, in the unsaturated vadose zone. D. As groundwater, below the water table, in the zone of saturation. And E. As atmospheric water, that is, the humidity of the air, partially or fully saturated. An ecosystem encompasses the characteristic flora and fauna of a certain geographical and climatic region. The key question is, where does a given ecosystem get its water? The answer is where it's more readily available, from any of the five sources listed above. Depending on a variety of factors, the typical ecosystem gets its water from a combination of these sources. In humid systems, they get it primarily from precipitation and surface water. In arid systems, from the near subsurface and groundwater. In superarid regions, from the groundwater and unusually from the air. This figure shows the deep roots of the mesquite tree, which can send its roots as much as 50 feet in search of groundwater. Another example is that of irrigated agriculture, an artificial, that is, anthropogenic ecosystem which usually gets its water from either surface runoff reservoirs or groundwater by means of pump wells. Precipitation is the de facto driver of natural ecosystems. Mean annual terrestrial precipitation has been estimated at 800 millimeters. On the dry side, the climate may be classified with decreasing moisture as semi-arid, arid, hyperarid, and superarid. On the wet side, the climate may be classified with increasing moisture as subhumid, humid, hyperhumid, and superhumid. Within these ranges, ecosystems are conveniently adapted to make use of whatever water is available to assure their survival, continuation, and preservation. Where precipitation is lacking, ecosystems will tap any of the other sources. The primary reliance on only one source makes that ecosystem highly dependent on the permanence or availability of that source, be it A. Surface water, B. Subsurface water, C. Groundwater, or D. Air. It follows that an ecosystem that normally taps only one source will find it difficult or impossible to survive if the availability of water in that source is somehow reduced or eliminated. Most plants draw water freely from the vadose zone, the extent of which depends on soil texture or rock type. The amount of moisture in the vadose zone is less in arid regions and more in humid regions. Some plants are able to get their water directly from the groundwater or else from the capillary fringe lying directly above it. The type and distribution of plants on the Earth's surface is determined by 1. Position along the climatic precipitation spectrum, from arid to humid. 2. Depth to the water table, which determines whether the plants can avail themselves of moisture in the capillary fringe or the groundwater beneath it. 3. The presence or absence of springs, which are a function of local geology and geomorphology. This figure shows a riparian corridor of coast live oak in Tierra del Sol, San Diego County, California. The creek is ephemeral, with surface water flowing only in response to rainfall. Yet there is enough year-round moisture in the soil of this semi-arid desert to support a healthy riparian corridor. Depending on local geology and geomorphology, springs may flow into wetlands, enabling the support of significant stands of vegetation. For instance, this figure shows a very large specimen of coast live oak located in the McCain Ranch, McCain Valley, Boulevard, San Diego County, California. The specimen, measuring 8 feet in diameter at breast height, is estimated to be at least 300 years old. The absence of this type of vegetation in the remainder of the arid McCain Valley, with 15 inches of mean annual precipitation, strongly indicates that this community of coast live oak is being sustained by groundwater originating in local springs. Groundwater pumping typically produces a cone of depression around the well location. The size of the cone of depression depends on the amount of capture, greater amounts corresponding to deeper cones. The water table and associated capillary fringe are abated as a result of the pumping. A conflict arises in the event that the pumped water is being used by the local ecosystem. Further abatement of the water table, continuing in spatial extent and duration, is bound to impose a hardship on the overlying ecosystem. In extreme cases, the vegetation could dry out and die as a direct consequence of the pumping. Thus, the viability of groundwater pumping is seen to be more associated with ecohydrology than with hydrogeology. Studies are needed to determine the extent to which a proposed groundwater development will lower the water table and the effect that this lowering will have on the livelihood of local vegetation. Indiscriminate groundwater pumping will cause water stress in local ecosystems, eventually leading to their demise. The resulting effect is poised to be the aridization, that is, the desertification of the landscape, which is reckoned by any standard to constitute a significant negative impact. A case in point is that of the dead coast live oak tree in Tierra del Sol, San Diego County, California, shown in this figure. This tree, whose age is estimated to be at least 100 years old, died in the year 2014, presumably due to local moisture stress and the consequences from it. The perceived societal need to pump groundwater is contrasted with the need of vegetative ecosystems to avail themselves of water and moisture from a diversity of sources existing in the environment. These are the following: A. Precipitation. B. Surface water and surface runoff. C. Subsurface water from the unsaturated zone. D. Groundwater. And E. The air. In general, plants choose a combination of these sources for their water needs, depending on the local climate, geology, and geomorphology. While some plants use several sources, others may rely primarily on only one source. Plants heavily dependent on one source are likely to readily find themselves in moisture stress if that source is substantially reduced or eliminated. Indiscriminate pumping of groundwater has the potential to negatively affect the livelihood and survival of vegetative ecosystems that rely primarily or are heavily dependent on groundwater. The resulting aridization of the landscape may be readily envisioned.